Hi, this lesson is about the unit circle. A unit circle is a circle with a center at the origin and a radius of 1. The equation of the unit circle is x squared plus y squared equals 1. So when you are on the unit circle, with respect to your angles, remember you have quadrantal angles at each of the axes. And so when you are at 0 degrees, because the radius is 1, the coordinate would be 1, 0. When you're at 90 degrees and you're on the unit circle, your coordinate is 0, 1. 180 degrees means you've only gone to the left 1 unit, so that's negative 1, 0. When you're at 270, which is the negative y-axis, you've gone down 1 unit, so it's 0, negative 1. And when you've gone around 1 full rotation, you're back at 0 degrees, so it's the same coordinate of 1, 0. So let's determine if the following point is on the unit circle. So this is a coordinate, an x and a y, and we want to know if it actually sits on the unit circle. So in order to figure that out, we're going to use the Pythagorean Theorem, which is that if I take one side squared, which is 3/4, and the other side squared, and if that equals 1, because 1 squared is 1, then it satisfies the unit circle. So 3/4 squared is 9/16. Root 7 over 4 squared is 7/16. Numerator is 16, so 16 over 16 equals 1. So your answer is yes, that this point is on the unit circle. So here we want to find the terminal point on the unit circle where your angle is 3 pi. Remember, 3 pi is another quadrantal angle, and it corresponds with the angle pi. So that means you've gone around 2 pi units and then pi more. 3 pi and pi are the same position, which is 180 degrees. So it's the same answer we got here in the first example, that the point at 3 pi is negative 1, 0. So the negative x-axis. So here we want to find, for example 4, we want to find the x-coordinate of the point in quadrant 3 that sits on the unit circle with a y-coordinate of negative 15 over 17. Okay, so this is important. We know we're in quadrant 3, so our answer for x must also be negative. So we solve the equation. Remember, our unit circle is x squared plus y squared equals 1, and we're solving for x. So square negative 15 over 17, and we get 225 over 289. We want to subtract that fraction from 1, which is what you see here. So that gives us x squared is 64 over 289. And when you take the square root of this, you normally would get two answers, plus or minus negative 8, plus or minus 8 over 17. But since, again, we know we're in quadrant 3, we're only interested in the negative answer. So the unit circle can be used to identify the values of your trigonometric functions at your quadrantal angles. Remember, that's at the axes, as well as all those special angles that we've been learning, the 30, 60, and the 45. And you'll get the same answers that you get when you were using your right triangle. So this is the picture of what that unit circle would look like. And notice that there are coordinates all throughout this unit circle that correspond to an angle. So for example, here, an angle of 30 degrees, which is the same as pi over 6, has a coordinate of root 3 over 2 and 1/2. That sits on the unit circle. So if I squared this, if I did x squared plus y squared, it would equal 1. It's actually on the unit circle. So the x-coordinate of all of these points represents your cosine value of your angle, and the y-coordinate represents the sine of an angle. So every point represents a cosine and a sine. So as an example, here circled in green, I want to show you how what you see on the unit circle corresponds to your right triangle. This is a 30, 60, 90 triangle. And we know that opposite of 60 degrees is root 3, opposite of 30 is 1, and the hypotenuse is 2. So remember, your cosine is 1/2, right? And here we're at 60 degrees, so the same thing I have here. So cosine is adjacent over hypotenuse, so cosine is 1/2, exactly what you see here. And your sine is opposite over hypotenuse. So opposite of 60 degrees is root 3 over 2, which is exactly what you see here. So all these points on the unit circle correspond to a ratio of either your adjacent over hypotenuse for cosine or your opposite over hypotenuse for your sine function. And then the other 4 trig functions can be found from sine and cosine. So for example, if I wanted to know what is the tangent of 60 degrees, so I know from my triangle that tangent is opposite over adjacent, so that is root 3 over 1, which is just root 3. But if I'm looking at the unit circle, it's also sine of 60 over cosine of 60. So I can take the information I know from the unit circle, which is root 3 over 2, divided by 1/2, which is the same as root 3 over 2 times the reciprocal, which is 2, and that also gives me an answer of root 3. So you get the same answer whether you're using the right triangle or the unit circle. All right, and so this is just repeating what I said. On the unit circle, the x-coordinate represents the cosine at that angle, and the y-coordinate represents the sine at that angle. So the unit circle is also a good review of the relationship between degrees and radians. So you can see all throughout, 150 is 5 pi over 6, 330 is 11 pi over 6, 5 pi over 4, that's 225. So the more familiar you are with all these angles in both degrees and radians, it makes it easier on you as well. So we're going to use the unit circle picture in order to evaluate the following trig functions, and there's several here. So we start with the cosine of pi over 6. Pi over 6 is right here, and cosine is the x-coordinate, so your answer is root 3 over 2. Now we move on to the sine of 4 pi over 3. 4 pi over 3 is in quadrant 3, and the sine, that's the y-coordinate, that's equal to negative root 3 over 2, which is exactly what you see here. And again, you could find this with your triangle, because at 4 pi over 3, that's 240 degrees. Your reference angle is 60 degrees here. So you have a 30, 60, 90 triangle. So you'd be able to figure it out like that as well. And then we have tangent of 7 pi over 4. 7 pi over 4 is here in quadrant 4. Remember, tangent is sine divided by cosine. So there's your sine divided by cosine. And when you divide those, you get that your tangent is -1. And that's because your reference angle, the angle between this and this, is 45 degrees. So your x and y values are the same number, except they're opposite signs, which is why you have a negative result. And tangent is negative in quadrant 4. So it should all be tying back to those triangles that we learned. Here we have the secant of 2 pi over 3. So 2 pi over 3 is in quadrant 2. Secant is the reciprocal of cosine. So the reciprocal of -1/2 is -2. And it also has a reference angle of 60 degrees. So you could also get it from the 30, 60, 90 triangle. And then we have the cosecant of pi over 4 is in quadrant 1. Cosecant is the reciprocal of sine. Sine is root 2 over 2. Remember, it's the second coordinate of your pi over 4. So the reciprocal is 2 over root 2. And so we rationalize that by multiplying top and bottom by root 2. And so your answer is just root 2. And again, we just took the reciprocal of what the value of sine is. All right, and then finally our last one, 7 pi over 6 is in quadrant 3. And we're looking for cotangent. Cotangent is the reciprocal of tangent, which means it is cosine divided by sine, which is exactly what you see here, cosine divided by sine. And when you change division to multiplication, cancel the 2's, 2 negatives make a positive, you get that your cotangent of 7 pi over 6 is a positive root 3. Okay, so that's how we use our unit circle in order to evaluate your trig functions at an angle. And these are all in radians, but you could also do this for degrees because everything here is also in terms of degrees. All right, so here's another interpretation that works as well. Here we're going to determine the reference angle, which is a good practice of a skill that you need, and identify each of the following trigonometric functions, again by using the unit circle based on what the reference angle is and what you know the sign, the SIGN, the plus or minus value of that trigonometric function. All right, so our first one is cosine of 7 pi over 3. So in order to find the reference angle, it would be helpful to know where 7 pi over 3 lives, because you don't see it anywhere on the unit circle picture. So I converted it to degrees, which is what you see here on the right. So it's 420 degrees. That means I've gone beyond one rotation. So I'm going to take, instead of subtracting 360, I'm going to take away 2 pi from 7 pi over 3, and that gives me pi over 3. So that means I'm in quadrant 1. I'm right here. And cosine is the first coordinate, which is a half, which is exactly what we got. And everything's positive in quadrant 1. 7 pi over 3 is in quadrant 1, so you don't have to adjust for the sign. Now we have the tangent of negative 4 pi over 3. So remember, when you have a negative, that means you're going clockwise instead of counterclockwise. If I were going counterclockwise, 4 pi over 3 would be in quadrant 3. But since I'm going clockwise, you end up over here. So if I add 360 to negative 4 pi over 3, that's equivalent to 2 pi over 3, which is in quadrant 2. But 2 pi over 3 is not a reference angle. Remember, reference angles have to be less than 90, and 2 pi over 3 is the same as 120. So how do you figure that out? Your reference angle will be pi minus 2 pi over 3. So I have a reference angle at pi over 3, which is again in quadrant 1. So pi over 3 is here. Okay, but tangent in quadrant 2, which is where negative 4 pi over 3 is negative. So when I look at my unit circle, I have to do sine divided by cosine, but remember, you have to carry that negative across. So I have the negative of sine divided by cosine, so my tangent value is negative root 3. So we're using our unit circle as well as our reference angle, and when you're looking at reference angles, you're always in quadrant 1, which means you might have to adjust for the sign depending on the angle where the original tan value lives, which was, this is in quadrant 2. And now there's one here in degrees, sine of 420. Now we just did 420 here, but this time in degrees. To convert it to a reference angle, I subtract 360 from it. So my reference angle is 60 degrees. So 60 degrees is in quadrant 1 as well as 420. So I am back here. And sine is the second coordinate, so it's got a value of √3/2. Okay, so that's it for this lesson. Give the homework a try. Good luck.